So to do that, I have made use of Spider. So I've created a similar kind of function here. The user passes on the input variables, the variables get captured at the backend, and then they are passed on to the saved model to make the predictions, and the prediction is passed on to the user at the front end. So here I have made use of Streamlit as a new library, because Streamlit is a library that allows you to create graphical user interface, web-based applications that can be hosted on a local server or on the cloud server. So here I have done a deployment on the local machine, and this is how it looks like. Okay. So let's say this is how the web interface looks like, and I'm going to test this with a similar kind of entry. So let's say the underwriter gets a new application, and the applicant's age is, let's say, around 36. Maybe the BMI index is around 29. The number of children, let's say, is only 1. The gender is male, and in the smoker, this time I'm going to select no. Okay. And then I am going to click on predict, and voila. So the insurance cost for this applicant is going to be relatively low. It's predicting to be less than 6,000. But interestingly, if I, for the very same person, happen to change the smoking status to yes, and then click on predict, then boom, you can see that the insurance cost has increased by a significant margin from less than 6,000 to over 21,000. That's like 3 times more. And that's the kind of impact smoking can have, negative impact, of course, smoking can have on anyone's life. And I here wanted to take the opportunity to highlight that. I have been a smoker myself for many years. However, now I'm proud to say that for the last 4 years, I have not even touched a single smoke. So here, let me try one more for a different applicant. Let's say the age is around 58. The BMI index is quite high. The number of children is around, let's say, 3. The person is, female, and let's say it's a non-smoker, and I'm going to predict that. And the insurance cost is coming around 15,000. So although this person is quite elderly, however, the cost of insurance is relatively less because there are no bad habits. But let's say if I change that over to male and a smoker and predict, and boom, you can see this is costing a huge sum of insurance, over 47,000, almost 48,000. Okay. So my model is working pretty well. It has been deployed, and I'm quite satisfied with the kind of responses, the logical responses that it is providing, it is rendering. And that essentially brings me to the end of this demonstration. So I'm going to quickly summarize. I have started off with the problem statement. Who is the target user for this application? And then I have started with importing the business data set. I have performed some data exploration. After that, I have performed some transformation within the data to make it more effective for the model training. And after that, I have imported 6 different types of machine learning algorithms in order to make sure that I do not run into the risk of choosing a wrong model or missing out on something. And then I have created a split within the data where I have given only 70% of the entire data as a training set to all the machine learning models for the models to observe the data and find any kind of patterns or behavior relationships within the data. And after that, I have used the remaining 30% of the data as a test data, and I have passed that on to all the models to see the predictions. Once the predictions have come over, I have compared them with the actual score, both visually, and at the same time, I have used some metrics like the R-squared metrics or the mean absolute error. And as a combination of all of that, based on the business context, I have decided to go ahead with the model, the prediction model, and that has been the gradient boosting regression model. And after that, I have tested some quick predictions with some new input variables. And finally, I have developed this interactive graphical user interface, and that I have hosted on a local machine or a local server environment, so that the internal users, which are the underwriter of the company, can access this application over the web browser. They can pass on the input variables as per the new applications received, and they can get the prediction as an output from the model. And on the basis of that, the underwriter can take a fair decision on how to evaluate that application and how to proceed with making a decision. So that's a wrap. And you have been seeing Soumyadip Chatterjee explaining how a machine learning application can solve a critical business problem. Thanks for your time. Feel free to connect with me over LinkedIn or Instagram, and I'll see you on my next